Welcome to video 6, some bearings examples. So what I'm going to go here is that we're going to complete one simple and one more complex bearing problem. So let's look at example 1. Luke walks 4 kilometres on a bearing of 330 degrees. How far north is he from where he started? So let's start with 4 kilometres on a bearing of 330. My rough planning tells me he'll be heading in that direction. So I'm going to start Luke here as an L. I'm going to walk him 4 kilometres in that direction, so we'll call this 4 kilometres. I don't need this to be a perfect diagram. I am going to put my little compass diagram here, so there's north. This is, of course, west, which is equal to 270 degrees. And so I know that this angle in here is 60 degrees, because he is walking at 330 from his original 270 west. And now I'm going to create a triangle out of this. And I'm going to take this triangle over here. So, taking everything else out of the diagram, here's my triangle, 60. I know that north and west are at right angles to each other. 4 kilometres here. And so now I've created a triangle where I have a known side, a known angle, and it's a right angle triangle. The question asks, how far north is he from where he started? So this side will represent how far north he is, because he starts at this level in terms of north-south, and he moves to this level in terms of north-south. So there we have it. So I'm going to do my solution to this using right angle trigonometry. And first of all, I note that 60 is the angle. I'm looking to find the opposite. I know the hypotenuse. So this will be a sine rule question. Sine of theta is equal to opposite over hypotenuse, which in this case, sine 60 is equal to n over 4. And so n is equal to 4 sine 60, and that's equal to 3.4641, in this case kilometres. I could just leave it as 3.46 kilometres. And now I'm going to go down and do example 2, which you may have already read from earlier. And of course, this is the Angela Sales question. So let's start this example. Angela Sales 20 kilometres on a bearing of 140 degrees. I'm going to pause it. So example 2 is a repeat of the earlier example from the last video. Angela sails 20 kilometres on a bearing of 140. So let's just quickly draw this out. Angela starts here. She sails 20 kilometres on a bearing of 140 to here. And here's my north, south, east, west. Here's my next one, because I know I'm going to need it again. She now travels north 35 degrees east, which is in this direction, but only 10 k's. Now, I'll put my 10 and my 20 on here. You'll note that I've deliberately left her ending point, which I'll call C, and B there, as slightly south of the starting point, but I don't really know whether she's south or whether she's north. So I have to be a little bit careful about making assumptions here. On what bearing is she from her original location? So let's complete this triangle there, and you'll notice that this is the bearing. If I get theta, and then I add 90 degrees to theta, or in this case I have to be a bit careful because theta may actually be on the other side, then this will give me my overall bearing. So what I really want to calculate is the values from this triangle. And if I can calculate this x value and this y value, which are x being how far east, I know she's definitely east, how far east of the starting point she is, and y being how far north or south of the starting point she is, well then I have a really simple right angle trig problem. So I'm going to go through and do that now by piecing it together, starting with this triangle here to see how far south and east B is of A. So we have 20 kilometres, and inside the triangle, because of the 140 degrees, I know that this angle is 40. I know that's a right angle triangle. So let's call this number 1. and start by redrawing my triangle. It's always a good idea to just take your time, make sure that you've got all the information correct. So we have 40, we have 20, we have a right angle, and I'm interested to know how far south, so I'll call that S1 because I will be using south and north later, east and west later, and so I'll call this east E1 for how far east she is after she gets to B. So here's A, here's B, and this is my imaginary point, which I'll just call O. So to calculate those, first of all, starting with south, I'll have that south S1 is the adjacent side, the known side is 20, that's the hypotenuse, and my angle is 40, so I can build my equations here as cos, because it's adjacent and hypotenuse, cos theta is equal to S1 over 20, and of course theta in this case is 40, so I don't need to write that down if I want to start a little bit quicker, and so I get S1 is equal to 20 cos 40, which is equal to 15.32 kilometres south, and sine, which is opposite, so sine of 40 is equal to E1 over 20, so therefore E1 is equal to 20 sine of 40, and this is equal to 12.856 kilometres east. This 5.6, I've gone to 3 decimal places because it wasn't very close to rounding to 2, so I've just taken that extra level to make sure I'm accurate. And so there we have our values to B. Now I'm going to do another triangle to represent our B to C section. Work out how far east, further east we've gone from B to C, and how far north we've gone back up to see if we've made it onto the north or the south side, and then build that last triangle. So our B to E triangle looks like this. So B to C triangle, and it's a right angle triangle. This is of course 10, and because we knew that they travelled north 35 degrees east, means that we know that this angle here is 55 degrees, or this angle here is 35 degrees. But I'll use the 55. I'm going to call this East 2, to not confuse it with East 1, and I'll call this North 1, because this time we're going north, so M1 will be fine. So now going across, I have, first of all, using 55 as my reference angle, and calculating north. That is, of course, opposite. So I have sine of 55 is equal to N1 over 10, and so N1 is equal to 10 sine 55, and this is equal to 8.19 kilometres. And then I have cos of 55 is equal to E2 over 10, and so E2 is equal to 10 cos 55, and this is equal to 5.736. Again, I'm going to be a little bit more careful with the accuracy of this one, and so I have the distance I've travelled north and east again, and I can see here that in total, my total east, which is equal to E1 plus E2, is equal to 12.856 plus 5.736, which of course is 18.592 kilometres. And my total south, I can see that I've travelled in total, I've gone south, because I travelled south 15.32 kilometres, then travelled back north 8.192 kilometres, leaving me with 7.13 kilometres. So it is my south one minus my north one, 7.13 kilometres. And so now I can put this into that final triangle, which was this one here. So here's A, my starting point. Here is C, my ending point. In total, I've gone south 7.13 kilometres. And I've gone east 18.592 kilometres. This is a right angle because I'm dealing with just east and south. And I want to calculate this theta, knowing that once I add 90 degrees to that theta, it will give me my overall bearing as a 3-figure bearing. So in this case, I know the opposite and the adjacent. So tan theta is equal to 7.13 over 18.592. So theta is equal to tan inverse of 7.13 over 18.592. And I've put this in my calculator. Again, you should be checking when you put these in your calculator, you get the same thing as me. And that gives me 20.98 degrees. And so in total, the approximate bearing, and I use approximate because I'm going to quite rashly round this off significantly. I'm going to call this 21 because it's very close to 21. So my bearing is 90 plus 21, which is equal to 111 degrees. And 111 degrees can be written as south. Remember, we start with south or north, and in this case we have gone south in total. South, 69 degrees east. And so there we have it. Two bearings examples. I know the second one was quite challenging. If we go back up to the diagram and have a look, it's quite a lot of steps, but overall the first one shows a simple example, the second one shows a challenging example, and hopefully you've got some information from that. All the best.